Okay, so now we are starting this. Here we are going to discuss the application of your Biot-Savart law. In the previous video, we have already discussed what your Biot-Savart law states and what is the use of Biot-Savart law, and all these things we have discussed in the previous videos. Now we are going to start with the first application of your Biot-Savart law. What is the application of Biot-Savart law? That it can help to calculate the magnetic field at any point, at any shape. We can apply the Biot-Savart law, and we can calculate the magnetic field at any point due to an finite and infinite long conductor or a loop. So we are going to start here. So first I am going to explain the diagram. Consider that we have a wire XY. Okay, we have a wire of length XY. Let P be the point. Let P be the point where we need to calculate the magnetic field intensity. Let phi be the angle which is made by, and here in this, as this is my 90 degree and this is my theta, so this I have given as phi. Let this whole, means the angle made by x to this point, let this angle be phi 1, okay, and the angle made by this particular, let we call this angle as phi 2. So I have made my two angles phi 1 and phi 2, which is going to cover whole area of this. Okay, let the point P is placed from point O at a distance r, and from point Q it is placed at a distance A. What I have done here, we can see that the magnetic field is perpendicular to this current carrying conductor, where the current is flowing in this I in this way. Okay, now here dl is the point where we have considered, suppose because of this small current or small length of the conductor, what will be the magnetic field at point P? So this is what we have considered. We have considered an XY conductor of length, it can be a finite or infinite, but this case we are doing for finite length. So the length of that conductor is XY. Let dl be the small element. Because of that, we are finding the magnetic field at point P, which is at a distance r. Okay, so from its center Q, let the point P will be perpendicular to this point, so that distance is A. So we are going to solving this. Okay, so understand this now. According to Biot-Savart law, what Biot-Savart law says, we already seen in the previous video that what Biot-Savart law says. It says that the dB is equals to mu naught upon 4 pi, okay, that is I dl sine theta upon, now at what distance it is placed? It is placed at a distance of r square, because I need to calculate the magnetic field because of this small element dl. That's why I am finding the field also, this dB also very small. If you will see this carefully, you cannot do anything with this. You cannot integrate because you don't know the theta, you don't know the values which we need to calculate. And here if you will see, we need to substitute the values, that what can be the values that has to become in place of all these. So now we will come back to this. So here you are finding one right angle triangle. So in right angle triangle, what is that? That is your OQP, right angle triangle OPQ. So angle Q is 90 degree. So what I can write here, theta plus phi gives me 90 degree, correct? So I can write here phi is equals to, or I can simply write here the angle as theta is equals to, here it is of plus 90 minus of phi. I can write here theta is equals to 90 minus of phi. We can multiply both the sides. Therefore, I have multiplied both the sides. So I will get sine theta is equals to sine 90 minus theta, or 90 minus phi. How I have written, this is clear, right? How I have done? Sine 90 minus phi will be what? This will be my cos phi. So I can say that my sin theta can be my cos phi. Let this be my equation 1 and I call this equation as A equation. Okay, let this equation be my equation 1. So I have calculated my sin theta value. I also need to know the value of my r from this given triangle. So again I will go to this triangle. Also we can see from here what is that? That is cos phi. Okay, cos phi. What is cos? Cos, if you remember in the trigonometric ratio, what is the value of cos will be? That is base upon hypotenuse. So what is your base? Base is A and hypotenuse is R. I can write it down this. Cos phi is equals to A upon R. So from here I can write it down. R is equals to what? This will be A upon cos phi. Let this be my equation 2. Okay. This will be my equation 2. Now again still one thing is missing, that is my DL. How I can calculate my DL? Again I will go back to the same triangle. This is only the hero. So what is that? That is tan phi is equals to, okay, what is tan phi? Tan is nothing but base upon perpendicular upon base. So what is your perpendicular? L. What is your base? Base is nothing but, if you will see from the triangle, it is A. So L is equals to what it will be? Tan phi into A. Okay, A into tan phi. Let differentiate this DL. When you are going to differentiate this DL, what you are going to get? Okay, here you are going to get this DL is equals to, A will come as it is, right? We have to differentiate. Tan phi will be what? Sec square phi d phi, correct? Because this I have differentiated how? DL upon d phi, DL upon d phi. So this I am going to differentiate and I am going to get this expression. Okay, let this be my equation 3. Okay, question come, why I am finding all these? So why I am finding? Because I need to substitute in this particular and I need to calculate what will be my magnetic field at point P. So when I am doing it, so that time what I have obtained, that sin theta will be, can be written as cos phi. Cos phi is A upon R, so R can be A upon cos phi. Tan phi will be L upon A, so DL will be A sec square phi d phi. Now substitute the equation 1, 2, 3 in equation A. Okay, by substituting equation 1, 2 and 3 in equation A, what you are going to get? You are going to get here dB is equals to mu naught upon 4 pi, that I will come as it is. What is the value of DL? DL is nothing but A sec square phi d phi whole upon, what is the value of R? If you will see from here, R will be what? R will be your A square cos square, correct? Cos square phi. Sin theta still left. What is the value of my sin theta? That is nothing but a cos phi. Okay. If you will see here carefully, what you will get? This cos will go up. So I will get my expression as dB is equals to mu naught upon 4 pi I A. So sec square phi d phi, or instead of d phi I am writing here cos phi, and that comes cos square phi whole upon, here it comes A square. So if you will see this A, say this square get cancelled. Sec square means 1 upon cos square. So this sec square and this is cos square is also cancelled. What I will left with? I will left with dB is equals to mu naught upon 4 pi, that is I cos phi whole upon A. This I am going to left with in the above expression. Now this is what I have obtained after substitution. I need to calculate that what will be the magnetic field at point P because of whole conductor. This is the magnetic field because of this small current element DL. I need to calculate what will be the magnetic field because of whole conductor, because of X and because of Why? So if you will see at point P, that point P is making an angle phi 1 with this and phi 2 with that. But if you will see, one is below the principal axis and one is above the principal axis. It means their limit will also change to minus to plus, and that changes from phi 1 to phi 2 like that. So this is we have done. Now what we have to do is we have to integrate it further. So when I am going to integrate it, what I am going to get? Okay, after this I am going to integrate it. Hope you have already written this. So after integration, what I am going to get? This dv, integrate dv, and here also we need to integrate mu naught 4 pi I cos phi upon a. This we need to integrate. From where to where we need to integrate? We need to integrate from minus phi 1 to plus phi 2. This is we have to, because now we are calculating because of x and y. This is for finite length we are doing. So we are going to get here mu naught upon 4 pi outside. I upon a will also come outside. What is left? Integration of cos phi will be what? This will be sin phi. I am writing it directly. This will be minus phi 1 and this will be phi 2. So substitution will be mu naught upon 4 pi I upon a sin phi 2 minus sin minus phi 1. Okay. So minus minus will turns to plus. So this will be mu naught upon 4 pi I upon a. This will be 2. So I am writing here. So this 2 and this 2 will get, means 2 and this will get cancelled. So what we are going to left with? We are going to left with the expression for this particular case. We have the expression as, or instead of this, okay, do one thing. Instead of this, we can have this mu naught upon 4 pi I upon a sin phi 2 plus of sin phi 1. Okay. So because we don't have the value of phi 1 and phi 2, that's why I am not writing here 2. But in the previous case, I will tell you that why I have written there 2. So this will be the expression for your finite conductor of length xy. Okay. This is the expression for finite length conductor. Okay. This is the expression for finite length conductor. So this way we are going to get now in the next video. Soon after this, the next video you have to watch for the special cases related to the magnetic field due to a straight current carrying conductor. Thank you.